Let's look at the solutions of algebra bytes now. How many integral solutions exist for mod x plus mod y is less than 25? Okay. Graph for this would be something like this. Cutoff points being 25 everywhere. So things that you have to see is the points that you identify on the axis, they have to be counted separately. They have to be counted separately, and whatever points you get in this portion here, they will get repeated in all the four quadrants. So let us count. When x is 0, y can take any value from 1 to 24 or from -1 to -24. So 48 cases here. When y is 0, similarly you'll get 48 cases for x, 1 to 24 or -1 to -24. There is one more case where x is 0, y is 0. We have taken care of all the cases that are on axis. Now we have to simply count those cases. In the first quadrant, I will count cases, and then I will simply multiply it by 4. When x is 1, y can take values from 1 to 23. When x is 2, y can take values from 1 to 22. When x is 3, y can take values from 1 to 21. So on and so forth. If I keep going, when x is 22, y can take values from 1 to 2. And when x is 23, y can take only one value. Can you see you get 23 cases here, 22 cases here, 21 cases here. Storyline keeps going till 2 cases here, 1 case is here. So in the first quadrant, the number of cases that you're going to get, in the first quadrant, the number of cases you're going to get is sum of first 23 natural numbers, which is given by 23 into 24 by 2. So 23 into 12, so 230 plus 46, so 276. And these are just the points in the first quadrant. They will get repeated in all the 4 quadrants. So answer, so 276 into 4. 276 into 4 gives me 1104. 1104. These many cases I will get. Additionally, I have 48 and 48 and 1. So 97 more cases. Add this up. Together, I will get a total of 1201. So answer should be option B. Next question. A farmer has 132 units of barbed wire fencing. With this, he encloses a field of a certain area. Which of the following is closest to the maximum possible value of the area of the field in square units? Okay. So if it's a field, like this. No, why am I making that up? Let me erase. The field, I don't know the shape of the field. The shape of the field is not given to me. So instead, what I should be looking at is a circle. So if 132 is given to me, so 22 by 7 2 pi r into 2 into r is equal to 132. Okay, cancel. This also gets cancelled. This gives me 3. So r should be equal to 21. If r is indeed equal to 21, we are looking at area now. So area should be 22 by 7 into 21 into 21. Cancel 3. So now I will have 22 into 63. So the answer that I will get here is 22 into 60. So 1320 122 into 60 plus 22 into 3 plus 66. If I add this up, I will get 1386. So answer to the question should be option B. One error that you can potentially make in this question is you might end up thinking that this is a square field. The error that I started with is a square field. But in case you want to maximize the area, it has to be a circle shape that you have to work with here. Next question, find the greatest positive integral value of x which will satisfy the inequality. This cubic expression is less than 0. Okay, we have a cubic expression. There is no way of solving this. The only way you can work with is try to plug in values. So if I put x equal to 1, I get 4 minus 8 minus 11 minus 3. No, x equal to 1 does not give me a 0 here. This doesn't work. Let me check with x equal to minus 1. So I get minus 4 minus 8, 11 and minus 3. No, this also doesn't work. Let me check x equal to 2. 4 into x cube is 32 minus 32 minus 22 minus 3. No, this also doesn't work. Let me check x equal to minus 2. I will get 4 into minus 8. So minus 32 minus 32 plus 22 minus 3. No, this also doesn't work. Hopefully you can see the process here is nothing but plugging in values and checking. And you should be patient enough to check from 1 to 5 and minus 1 to minus 5. You should be patient enough to check these many values every time. So you've done x1, x minus 1, x2, x minus 2. Let's check at x equal to 3. 4 into x cube, so 108 minus 72 minus 33 minus 3. And yes, this does indeed turn out to be 0, which means that this expression will be divisible by x minus 3. So let's divide it. I have 4x cubed minus 8x squared minus 11x minus 3 divided by x minus 3. So first I get 4x squared. So 4x cubed minus 12x squared minus plus of 4x squared minus 11x minus 3. So I get another plus 4x now. So 4x squared minus 12x, nothing here. So this becomes minus, this becomes plus, this becomes x minus 3. So we get another plus 1 here. So the original expression has now turned to x minus 3 into 4x squared plus 4x plus 1 is less than or equal to 0. The second expression is a quadratic and it is very simple to see. It is 2x plus 1 whole square. So it is x minus 3, 2x plus 1 whole square. Now graphically what this would appear as is this. Graphically what it would appear as is this. There are 3 roots, but we are only able to see 2 of them. It would only happen. See, after 3 it is going to go upwards. After 3 it is going to go upwards, but at minus 0.5, this is how the graph would look like. Oops, this has become too fast. Go away. It would appear this way. This is how the cubic function would look like. So when they're asking me the greatest positive integral value, it has to be 3 only. Answer to the question is 3. Next, which largest positive integral value of x satisfies the inequality? This. Okay. So x minus 5 by x minus 2 minus 6 by x square minus 4 is greater than equal to x by x plus 2. Hopefully denominators everywhere give you the idea. A minus b, a plus b is in play. So we'll get x minus 5 into x plus 2 minus 6 upon x minus 2x plus 2 is greater than equal to x into x minus 2 upon x minus 2 and x plus 2. Now please don't make the error here of cancelling out the denominators on both sides. Please don't make the error of cancelling out the denominators on both sides, because we don't know if x is equal to 2 or x is equal to minus 2. Those are still possibilities, so you cannot randomly cancel them out. Zeros can't be cancelled. Okay, once we have got this, the expression turns to x square minus 3x minus 16 is greater than equal to x square minus 2x upon x minus 2x plus 2. And this is x minus 2x plus 2. So we bring the terms from the right to the left, and we have x plus 16 by x minus 2 x plus 2 has to be less than equal to 0. Okay, we have reached this expression. Now on a number line, just look at the key points. We have 2, we have minus 2, and we have minus 16. These are the behavior change points. Can I have x equal to 2? Can you see anything greater? Anything on this side will be positive only, because x plus 16 will be positive, x minus 2 will be positive, x plus 2 will be positive. So this portion is of no relevance to us. At x equal to 2, the denominator will turn to 0. So 2 is also not possible. And the question was asking which is the largest positive integral value of x, largest possible. Everything greater than 2 is ruled out. 2 is ruled out. The only number left to check is 1. If x was equal to 1, I would end up getting 17 by minus 1 into 3. Is this less than 0? Yes, it is. So the largest positive integral value of x that satisfies this inequality is 1. Last question. 3 natural numbers are in arithmetic progression with a common difference equal to 8. So let those 3 numbers be a plus 8, and a minus 8. Okay. If the first and second numbers are reduced by 4, first number is reduced by 4, I get a minus 12. Second number is reduced by 4, I get a minus 4. The third number is increased by 4, I get a plus 12. Okay. The resulting numbers are in geometric progression. Okay. These are in geometric progression, or another way of saying it is a minus 4 whole square is equal to a minus 12 into a plus 12. What is the sum of the 3 numbers that are originally in arithmetic progression? The sum of these 3 numbers is clearly 3a. Sum of these 3 numbers is clearly 3a. So I simply have to identify the value of 3a from here. I get a square minus 8a plus 16 is equal to a square minus 144. So a square gone. 8a is equal to 160 and a is equal to 20. What we finally need is 3a. So answer has to be option B. Hopefully nobody fell into the trap of taking the 3 variables as a plus 8 and a plus 16. See, whenever you have 3 numbers or 5 numbers, odd count of numbers which are in AP, always take the middle term as a. the processing is simpler, because in this case, see, not that mathematically it would be wrong. If this is reduced by 4, so this becomes a minus 4. If this is reduced by how much? 4, so it will become a plus 4. Then this is increased by how much? 4. Increased by 4. So this will become a plus 20. So now these numbers are in GP. So now you would do a minus 4 into a plus 20 is equal to a plus 4 whole square. So this gives me a square minus 4a plus 20a, so plus 16a minus 80 is equal to a square plus 8a plus 16. Cancel and cancel. This comes to this side. So 8a is equal to 96, a is equal to 12. So this is 12, this is 20, and this is 28. The summation will still turn out to be 60. That is not a problem. But hopefully you can see the numbers here are much smoother to deal with. That will be all for this episode. Hope you learned something. Okay, bye.